All right. In this lesson, we'll look at finding the volume of solids formed by rotating a region around the x-axis. So we've seen how to use integrals to find area, and we did that by looking at rectangles that had a width of dx, and we could do the integrate from 0 to 2. We did top minus bottom, so that was x squared minus 0 dx, and that was the area. So today we're going to have something similar. We'll look at that rectangle, but now that rectangle is going to rotate around the x-axis. So it rotates out and around, and it would create a cylinder like a coin. If we just look at that rectangle as it rotates, we'll make a thin cylinder like that. The radius of the cylinder is determined by x squared. So we could say that that radius of the circle is top minus bottom, just like we've been doing with area. So now we have a radius of a circle. We could say that the area of the circle is pi r squared, and here the top of the rectangle is x squared and the bottom is 0, so that means that the area would be pi r squared, but r is x squared because we had top is x squared, the bottom is 0. The top is x squared, the bottom is 0, so that gives us the radius. And then we could look at the volume of the cylinder. So here we have area of a circle, which is just the face, but if we look at the height or width of the cylinder, now it's just going to be pi r squared times the thickness, which is dx. Pi, that's r squared dx. Because just like we did with area, we have a differential of x here, we have a differential of x there, and that creates the volume of the cylinder. If we look at an infinite number of cylinders, we'll make this solid shape figure, because all of these rectangles are rotating, and so then we get this and to find the volume of the whole thing, we just look at the volume of infinite cylinders. That's going to be the integral from 0 to 2 pi x to the 4th dx. So we get an area of a circle multiplied by the differential, that gives us the volume of a cylinder, and then this integral is adding up an infinite number of those cylinders. This is when we have the region that is adjacent to the axis of rotation. Let's look at what happens if it's not adjacent. So they'll intersect at 1. We want to have that region rotate around the x-axis. So that means we're trying to find, I won't draw it that way, I'm just going to do it this way. We need to look at the solid created by F. F is rotating around, and then we'll subtract the solid created by G. Eventually we're going to have just this leftover rectangle that rotates like that. But to get there, let's focus on just F and then just G, and we'll subtract. All right, F, G, and the axis, here's how we find the radius. It goes, the radius is always from the axis of rotation. So we're rotating around the x-axis, and the big radius is going from the axis to the furthest part of the region, and so that's going to be top minus bottom. The top of this is going to be F, so that's x, and the bottom is 0. Then we can find little r, and little r goes from the axis to the closest part of the region, and little r is top, which is G minus 0, which is G is x squared minus 0. And we can then find the area of large circle. The area of the large circle, if I just rotate the red line around, we make a circle, and that area is pi r squared, pi r squared. And the area of the small circle is, if we rotate the small radius around, we'll have pi r squared. And then, rather than having, we don't want both circles, we want to cut the small circle out of the large circle. So we can say that the area of the washer, they usually call it a washer, and this type of washer is the one used with nuts and bolts, where you have something like that, and then you have the nut. There's the washer. That's what they call it, a washer. Area of the washer is just going to be the large circle minus the small circle. Large circle minus the small circle. Volume of washer. There's the volume of the washer, because we just multiplied by its thickness or its height. So over in this picture, if we look at the face of the washer, we'd find the area. If we multiply by its height, in this case it's dx. Over here it wouldn't be dx, but that's the dimension we're talking about. Then we can find the volume of infinite washers, and here we're going to use the integral from 0 to 1, and then just integrate that. find the volume of the solid formed by revolving the region bounded by x squared plus 2 x-axis x equals -1 x equals 1 about the x-axis. So I just have to write this much for the first time so you can see all the vocabulary, and then we'll shorten it. So we're going to find the volume of a solid. The solid is created by taking this region and rotating it about the x-axis. Okay, so the first step is draw the graph. And we're going to go to, it's a parabola shifted up 2. Here it starts at x equals -1, ends at 1, and it's bounded by the x-axis. It's also rotated about the x-axis, so we want to make sure we identify the axis of rotation. And here's the region. So this region is rotating around the x-axis. Let's look at, are we going to use a vertical or horizontal rectangle? And I would say always use a vertical rectangle if possible. So as long as every vertical rectangle has the same top and bottom, then we can use a vertical rectangle. So here we're going to use vertical, and that means we're going to use dx instead of dy. Since we're using dx, then we need to know the x interval of the region, and the x interval goes from -1 to 1. Alright, let's look for the radii. And here we're just going to have one radius because the region touches the x-axis. So let's just, but by considering that there could be 2 radii, that's preparing for other types of problems. So here we know that the axis is the x-axis. The axis of rotation is the x-axis. So we go from the axis of rotation to the furthest part of the region, and that will be big R. Then go from the axis to the closest part of the region, but the closest part of the region is on the axis, so little r is 0, and we just have to use big R as the top minus the bottom. And the top is x squared plus 2. The top curve is x squared plus 2. And then we subtract the bottom curve is the x-axis, y equals 0. So now we have the radius. And since I said radii, why don't we just say little r is 0? We don't need to worry about it here. All right, now let's find the area and usually the vocabulary used to describe this when the region touches the axis, they say use discs. So we have the disc or the washer, and here we have this radius rotating around the x-axis. We need the area of the circle created by rotating that, area of a disk. That's pi r squared. Pi r squared. The volume of the disk is pi r squared dx. And by integrating, we are adding up the volume of infinite disks. So we just take this representing one disk and integrate from -1 to 1. And if we do that on a calculator, we should get that. So instead of writing everything that I wrote before, let's just say here's the region and here's the axis of rotation. And we're going to find the volume of the solid generated by rotating the region around the axis of rotation. Pause the video and try this one. Sine. And we're going to go from 0 to pi over 2. Pi over 2 is here. So we're just taking that region and rotating it around the x-axis. So that will make something like that. And let's look at, in this region, can we use vertical rectangles? Yes, let's use a vertical rectangle. And that means we're looking for dx, or we're going to use a dx. We're going to use an integral in terms of x. And so that means we need the x interval. If we're using dx, then we need the x interval. And the x interval of the region is from 0 to pi over 2. Let's find the radii. Here it'll just be a radius because the region touches the axis. So we have the region and the axis. The big radius goes from the axis to the furthest part of the region, so that's big R. And big R is going to be top minus bottom. The top is sine. The bottom is 0. Little r, if we go from the axis to the closest part of the region, it's 0. We don't go anywhere. There's no space between the axis and the region, so little r is 0. So we have the radius. Now let's find the area of a circle. So when we rotate the red line around the axis of rotation, the area is going to be pi r squared pi sine squared. Volume of cylinder. No, I said disk before. Volume of a disk. The volume of a disk is just when we multiply it by dx. Remember that that 2 is the same as that 2. We can write it like this or like that. Volume of a disk, and then volume of infinite disks. integrate from 0 to pi over 2. And using a calculator, we get that. This is a region, solid, that will have a small r. It has a big R and small r. So let's look at how that happens. Negative radical is going to go like this, and negative x squared goes like that. So this is G and F. And can we use a vertical rectangle? Does every vertical rectangle have the same top and same bottom? Yes, we can use a vertical rectangle, and that means we need to have the integral in terms of x. We need, I'm going to pause the video and we will have a part 2.